The Defense Research and Development Organization, DRDO, has developed an indigenous high-pressure nanoporous multilayered polymeric membrane for seawater desalination. Purpose and strategic importance. The project was executed by Defense Materials Stores Research and Development Establishment, DMSERD, Kanpur, under the Atmanirbhar Bharat initiative. The membrane was designed to meet the operational needs of the Indian Coast Guard, ICG, particularly to withstand chloride ion-induced instability in saline water. The technology is intended for use in offshore patrol vessels, OPVs, of the Coast Guard, providing self-reliant onboard freshwater capability. About desalination technology. Desalination is the removal of dissolved salts and minerals from saline or brackish water to make it fit for human use. Two primary technologies used globally. Reverse osmosis, RO, pressure-driven membrane-based filtration. Thermal desalination, evaporation condensation method using heat. A desalination plant converts seawater into fresh water by removing salts to meet drinking or industrial quality standards. Working of reverse osmosis, RO, desalination. Osmosis refers to the natural movement of water from an area of low solute concentration to high solute concentration through a semi-permeable membrane. In reverse osmosis, external pressure is applied to push water from a high solute, saline, side to a low solute, freshwater, side, against the natural osmotic gradient. Microscopic pores in the RO membrane allow water molecules to pass while blocking salts and other impurities. Seawater typically has a TDS, total dissolved solids, of 35,000 ppm, while RO brings it down to 200 to 500 ppm, making it potable. What is desalination technology? Desalination refers to the removal of salts and minerals from water. Today there are two main types of desalination technologies. Reverse osmosis. Thermal desalination. RO desalination. Reverse osmosis, RO, desalination uses the principle of osmosis to remove salt and other impurities, by transferring water through a series of semi-permeable membranes. Osmosis involves a solvent, such as water, naturally moving from an area of low solute concentration, through a membrane, to an area of high solute concentration. A reverse osmosis system applies an external pressure to reverse the natural flow of solvent, and so seawater or brackish water is pressurized against one surface of the membrane. This pressure causes salt-depleted water to move across the membrane, releasing clean water from the low-pressure side. Seawater has total dissolved solids, TDS, i.e., a measure of salinity, close to 35,000 parts per million, ppm, or equivalent to 35 g of salt per 1 liter/kg of water. An effective network of RO plants reduces this down to about 200 to 500 ppm. There are about 18,000 desalination plants in the world across 150 countries, and nearly half of Israel's water is sourced through desalination. Environmental issues with RO desalination plants. Desalination is an expensive way of generating drinking water as it requires a high amount of energy. The other major environmental challenge it poses is the deposition of brine, highly concentrated salt water, along the shores. The brine being deposited along the seashore is triggering changes along the coastline and reducing the availability of prawn, sardine, and mackerel. Hypersalinity along the shore affects plankton, which is the main food for several of these fish species. Moreover, the high-pressure motors needed to draw in the seawater end up sucking in small fish and life forms, thereby crushing and killing them. Is RO water good for health? Earlier, there were concerns that desalinated water was devoid of vital minerals such as calcium, magnesium, zinc, sodium, potassium, and carbonates, referred to as TDS. Highly desalinated water has a TDS of less than 50 mg per liter, which is pure, but does not taste like water. However, anything from 100 mg/L to 600 mg/L is considered as good quality potable water. In today's times, Most RO plants put the water through a post-treatment process whereby salts are added to make TDS around 300 mg/L. Several of the home RO systems that are common in affluent Indian homes also employ post-treatment and add salts to water. Alternative to RO desalination technology. Low-temperature thermal desalination, LTTD. LTTD technique works on the principle that water in the ocean 1,000 or 2,000 feet below is about 40 C to 80 C colder than surface water. Salty surface water is collected in a tank and subject to high pressure, via an external power source. This pressured water vaporizes and this is trapped in tubes or a chamber. Cold water plumped from the ocean depths is passed over these tubes and the vapor condenses into fresh water and the resulting salt diverted away. LTTD plants in India. In 2005, National Institute of Ocean Technology, NIOT, set up a 100,000-liter a day plant in Kavaratti, Lakshadweep Islands, and this has been providing water to about 10,000 residents. There are also 1.5 lakh liters a day plants proposed at Amini, Androth, Shidlat, Kadamat, Kalpini, and Kiltan Islands. There are plants of similar capacity proposed at Minipoi and Agatti Islands. News summary. The National Institute of Ocean Technology, NIOT, is planning to set up a desalination plant in Lakshadweep. The plant will be emission-free. Currently the desalination plants, each of which provides at least 100,000 liters of potable water every day, are powered by diesel generator sets. The need for diesel power to reduce the water pressure means that the process is not fossil fuel free. Also, diesel is a precious commodity in the islands as it has to be shipped from the mainland, critical for powering the electric grid. Currently there are 5 desalination plants in operation in the Lakshadweep Islands. 4 more were expected to be functioning in the coming months. The proposed self-sustaining plant, the 10th, is expected to be ready later this year. About National Institute of Ocean Technology, NIOT. The NIOT was established in 1993 as an autonomous society under the Ministry of Earth Sciences. Objective: to develop reliable indigenous technologies to solve various engineering problems associated with harvesting of non-living and living resources in the Indian Exclusive Economic Zone, EEZ, which is about 2/3 of the land area of India. Headquarters, Chennai, Tamil Nadu. What is osmosis in simple terms? In biology, osmosis is the movement of water molecules from a solution with a high concentration of water molecules to a solution with a lower concentration of water molecules, through a cell's partially permeable membrane.